questions. So where are we? What did we talk about yesterday?
We talked about patterns a bit more, and you said you were going to bring up PA5.
Yeah, we talked about Huffman coding, right?
Yeah. Yes.
Okay. So let's talk about PA5, and then we're going to get into networking. And what the heck, we'll talk about Lab 5 too.
Seems intimidating.
Lab 5?
You know, you're saying it has to do with servers and connecting stuff.
Yeah, it's good stuff.
What about PA?
It's also PA5. There's a theme. All right, so PA5, so we're doing client-server models. So we're going to talk about what that means, but roughly speaking, a server is a thing sitting out there, usually on the net somewhere, waiting for requests from users, which we're going to call clients. And a client comes in with a request, and the server accepts the request from the client and does something, and often returns information. So for example, systems used to have a time server, and you could talk to a machine out on the net and say, hey, tell me what time it is there, and it would send you back a string telling you what time it was. There's a ping server. If you just want to know if a machine is alive, you can talk to the ping server and say, hey, send me back a ping if you're there, and it'll send back a ping, right, a message which identifies. There's mail servers. If you want to send mail to a machine, you can connect to a particular server and send it a message in a particular format, and it will read that as a message and deliver it to someone on the system. There's web servers. So if a system has a web server running, you can connect to that server and say, hey, find a file on your system with this name, and it will pull up the contents of that file and send it to you as an HTML file. So your web browser in that case is what we call a client. So there's servers and clients, okay? It's a standard model. And we use this when we connect to the Linux machine, so I always call it the Linux server. This is the reason why, right? It's basically sitting out on the net, and there's a process running called SSHD, and it's waiting for connection requests. When you run PuTTY, PuTTY is a client, and your client talks to the server on linuxengrcs.com and says, I'd like to start a login session, and the server does things to create a process, and so on and so forth. So for PA5, you're going to implement a client-server pair. Okay, so we're going to talk about what this means and how to do this, and we're going to go through some classes in Java to support this, but ultimately what you're going to do is you're going to create a chat program, okay, in Java, and you're going to create both the client side and the server side. So two separate programs, okay, with a number of classes in each. So your two main programs, there's a server, okay, which is going to be a class named server main, and a client, which is called client main. Clients connect to servers by using something called a port. So let's look at the internet. Right, so here's a server. It's got an IP address. If it's old school IPv4, it's got 4 pieces to its address. 192.168.0.1, if you're on your home network, is usually the address of the router. But it's something, right? At Clark, it's 10.0.something.something. And some of these addresses are local to your local intranet, right? If you have a router at home, all your addresses look like 192.168 something. But some of these are actual addresses like on the worldwide internet. Okay, and this particular combination of 4 numbers points to a particular location, a particular device somewhere on the net. And so your client can ask to talk to a machine by using an IP address, as well as a particular location on that machine called a port. So the IP address and the port combination identifies a unique piece of software running on the server. And so this was a whole lot easier in the 70s and the 80s, right? Before everything was networked and we started worrying about security issues. Everything was wide open, everything was accessible. And now it's a little harder. But it used to be that these were typically the services that were available on a Unix machine. So port 7 was an echo. You could connect to port 7 on a machine, send it something, and it would send it back to you. And it was an easy way to establish that a machine was there and get connection going. 13 was a port associated with daytime, right? So it would tell you what time it was. 15 was netstat, so it would give you information about different connections that were available. And the three main ones we used were 21, which was File Transfer Protocol, FTP, so you could connect to port 21 on a machine, and it would ask you for a login. You'd send your login. It would ask for a password. You'd send your password in plain text, and then it would establish a connection, and you could say, get this file, put that file, right? 23 was Telnet. That was the way you established an interactive login session. So you'd connect to port 23, it would ask for a username, it would ask for a password, and then it would be like if you had connected through PuTTY. And 25 was the mailer, so Simple Mail Transfer Protocol, SMTP. You'd connect to it. You didn't need a username or password. You could simply connect to port 25 on a machine and exchange information in a very particular format. You could say message from, colon, put in who it was from, recipient to, colon, say who it wanted to go to, and then say body, type in your text, hit a line with a period on it, end, and it would deliver mail on that machine. And it could come from you, it could come from the President of the United States, or Skynet, or whoever, right? So all very open, but not practical today. So a lot of these things don't get used anymore. Port 22 is labeled SSH. That's the secure shell. That's the one that typically PuTTY connects through. And it's like a telnet connection, but it puts a layer of encryption on there. So it's more secure. So there's all these different ports available, right? 79 was the finger port. So you could use, make a connection to 79. It would just send you what you get back when you type the finger command, which gives you a list of everybody that's logged into the system and information about them, how long they've been idle, and so on.
Doesn't W do the same thing as well?
Say what?
Doesn't just typing W do the same thing as well?
Not quite. But when you say finger, I think it's actually talking to port 79, or I used to talk to port 79. So most of these things aren't available anymore, right? They have to be explicitly turned on. Oh, but port 80, right, that's HTTP. So when you want to access a web page, you connect to port 80 and you say, give me this page, and it sends it to you. That's the insecure version, usually 8080 or some other higher numbered port is used.
Oh, I think I saw 400 something HTTPS.
Okay, yeah. So yeah, lots of services out there. And it's all based on the same client-server model, okay? And you can make your own servers and your own clients and talk back and forth like that.
And so is this just a list of like standards?
Those are a list of standards, yeah.
That's awesome.
Like I say, many of which don't exist anymore, but some of these, if you're doing gaming, right, there's a standard set of ports that are used for different kinds of
Curtis, not to overstep the bounds.
Yeah, and port numbers below 1024 are privileged, so you can't bind things to those addresses unless you have root access. Above, it's the Wild West. And here's, I'm back on the Linux server, right? Here's a list of everything that's currently going on the system. So established, well that's me because I'm the only one logged in. So there's a connection to port 22. This is the current SSH session sitting out there. and there's lots of servers waiting for connections. What?
And it has your address.
And it has my address, yeah.
That's cool. Okay.
What are we doing now? Because I just connected. I want to see the changes.
Oh, yeah.
Just curious to see what happens.
Except I broke it. No, actually, maybe I just lost my connection. There we go. All right, so now we got two connections. Are you connected?
Me?
Yeah.
Yeah.
Hmm. So
Should be at least. Yeah.
it's interesting. We're both coming from the same address.
Well, aren't you on the same number?
Yeah, I guess so. All right, so one of those is you, one of those is me.
Now what grep means here? Why do you have...
grep is a search, so I just wanted to look for the ones that said TCP.
I was like, what do you have 132 on there? But he doesn't. Does that just be the command types?
So what's the 132? I think it was the send queue. So that was how much was queued up to go out.
Oh, okay.
I don't know what most of these fields, but that was transient. What's our ODP?
Okay. It was my bad then. I was reading your command as if it was a label for the table.
Okay. What am I doing here? I'm looking for something. Okay, we'll do that later. Anyway, so so you can create different servers, right? Clients talk to servers. So what's your goal here? So you're going to make a pair of classes, okay? Server main and client main. Client main will basically sit and wait for, server main will wait for connections. Client main will establish a connection to it. So we're going to talk on port 1201, okay? So you're doing this on your own system, not the Linux server. Okay, if you try to do it on a Linux server and everybody uses 1201, only one person will succeed. So you're doing this on your own machine. And you're going to connect to your local host, okay, which you can get to through localhost, or your local host is always 127.0.0.1. That's a reserved IP address for whatever machine you're currently on. You're going to connect to the server through port 1201, and then you're going to do the following. Type stuff in on the client, hit enter. It should transmit that to the server, okay? At the same time, if you're sitting on the server, you should be able to type stuff, hit enter, have it show up on the client. Okay, so it's a two-way chat between the server program and the client program. Okay, when the client exits, so end of file, Control-D or Control-Z, right, things should shut down gracefully and the server should go back to waiting for another connection. Okay, so think of this as like a help desk model. Okay, the server is the help desk that's always sitting there ready to chat. Clients can come in, they can run your client code to connect to the server. You can have a two-way conversation going on. The client can exit, and then the server goes back to waiting for another connection. Okay. And I don't think I have anything in here about multiple connections. Huh, okay. Okay, I made this a little easier. So that's all you have to do, okay? But if you want to embellish this, right, what are your options? Well, one, you can make this GUI based, okay? You can use Swing. You can establish, you know, type in the IP address and hit connect and put up a window you can type in and another window where you can see messages coming back to you and so on and so forth. You can also try to set it up so that you can have multiple chats going on at once, okay? But bare minimum, server, client makes a connection, two-way chat, okay? So, and this is a group project, okay? So that's the additional thing to note. So you can work in groups on this. I'm gonna say up to groups of 3 people, okay? But you want to make sure that everybody in the group does every piece of this. Don't just say, I'm gonna make the client, you make the server, and never look at the server code yourself, okay? Because you want to understand the whole system. And they're slightly different, making a server versus a client, but they're fundamentally the same once you get things started. So make sure that everybody in the group is doing all the parts and pieces, because this will be on the test. But you can work in groups of up to 3 people, which means at least one person in the group wants to have equipment that you can work on, okay? And typically you can run your client in one window, run your server in another window, and communicate like that. You can do this in Eclipse if you like, okay? Eclipse will let you run multiple things at the same time. It'll let you open up multiple console windows so you can type in one and see it coming out in the other and so on, but you can also do this on the command line. And just working on the command line I think is a little easier, because you can just make 2 console windows and just go from there. One other thing I wanted to say. Oh yeah, so you're going to demonstrate this in class. So however you set it up, however you embellish it and so on and so forth, you get to show that off in a demonstration. So, you know, a few minutes per group, you'll come up here and show the class your code. Okay, this has a due date of Monday, so it's a week from this coming Monday that it's due, because I don't want something due on the last Friday, because then there's no time for feedback. So this is a shorter one, but you're working in groups, and the basic behavior is fairly straightforward once you know how to make a client-server connection. So let me tell you the part that's not so straightforward. So here's your client, here's your server. So first thing you're going to do is run the server, okay, before you try to run the client, because the server is a thing that the client connects to. So step 1, you're going to start the server code. Bless you. Step 2, this is going to wait for a connection request. Step 3, you're going to run the client, which will make a connection request. Step 4, the server will accept the connection request. And now you've got basically this. You've got this two-way pipe, and you can send and you can receive on each side. And we can use a scanner to read from this. We can use a print writer to write to this. Okay, you have to construct them with information from this two-way portal. But once we do that, we can use has next line, we can use print writer dot print line and so on. So same thing we've done for standard out and for files. But here's one tricky aspect of this. So your client is supposed to let you type something in hit enter, and it'll send it over to the server, right? So you might do something like read a line from standard in, send to server. And if we just do this in a loop, we can keep typing, hitting enter, and it'll keep going over to the server. And the server might do something like read from client, print to standard out. And this could loop, and this could loop. And now the client can type, hit enter, type, hit enter, type, hit enter, and the server keeps showing what the client typed. But what happens when the server side wants to type something in and send it to the client? So we've got to have something over here which is reading from the server and printing the standard out. And one way to do that is read from standard in, send it to the server, and then read from the server, print to standard out, and then go back up. And over here we read from the client, print to standard out, and then read from standard in and print to the client. So now each side can type, hit enter, and the other side will show it. But there's a problem with this. So what's the problem? It's kind of subtle. So imagine you're the client and there's a server that's running that code.
Kind of hard to write your own messages with their messages popping up on the cursor.
That could be a problem. Is that going to happen?
Because doesn't standard out just kind of print where your cursor is, right?
Right, but we only print from standard out after we've read from standard in and sent it to the server.
Oh, well, then you're going to miss a few messages until you press enter.
Yeah. Or they're going to stack up.
Yeah.
So the problem here is that these two things are moving in lockstep, right? So client side, type something, hit enter, okay, it reads that line, sends it to the server, and now it's waiting to read something from the server. And I can't send another message until the server has got something to send and sends it back to the client. Now I'll read from the server, print it to standard out, and come back. So this only lets you type one message at a time. It only lets the server type one message at a time, and you got to take turns. All right, client sends, server sends, client sends, server sends. That's not what we really want in a chat program. We want to be able to spam the server, or just keep typing things and sending, or just pipe War and Peace into it or something. And while somebody's over here typing, they can be seeing what you're sending. Right? That's sort of a usual chat program. So we got to break this lockstep. And how do we do that?
Using threads.
Using threads. Perfect. So make one thread that does this, make another thread that does that. And same thing on the server side. So now while the person is typing in, and this is waiting for the person to hit enter so they can send it to the client, this thread is still reading from the client. And every time a message comes in, it prints it out, goes back, waits for a new message. And same thing over here. So you're going to want to use threads in here. Okay. So once we've got the connection request, you've got some more steps, which is basically create a new thread to handle one side of this communication, and then go into a loop to do the other side. Or create two threads if you want, one for each side. And then your server could actually go back to the beginning, wait for another connection. Now you can have multiple clients talking to you at once. And there's all kinds of ways you can go from there. Okay, so that's the basic goal. Client-server chat model, simultaneous communications. Okay, so that's this part up here. Wait for the user to type input, and once the enter key is pressed, transmit that entry to the other program. At the same time, whenever input arrives via the socket, that's the communication pipeline, it should immediately be displayed without waiting for the user to hit enter. All right, so how do we do this? Well, this pipeline is basically a connection between two endpoints that we call a socket. So a socket is this kind of virtual thing that we're going to create, and we create a socket and the server creates a socket, and we get those two sockets connected to each other. And the socket is kind of like a file pointer in C. If we write into our socket and something reads from that other socket, it will read whatever we wrote. Okay, so it's like a pipeline, and vice versa. So the main class we're going to use, not surprisingly, socket. So it's a Java class. So socket is constructed with an internet address and a port number. Okay, that's how you identify something out there that you want to communicate with. And it can be an INET address, which is a 4-part or 6-part numeric coded, or it can be a string, which is linux.engrcs.com or whatever. Or the string, quote, localhost, if you want to be on your local machine. Or it could be a string, quote, 192.168.5.3 or whatever. And it will return a socket. Okay, that constructs a socket, so you get a socket out of it. And then once you have a socket, you can basically say get input stream or get output stream. And
Or you can see what you sense.
well, it associates another type of object called an input stream, for example, with that socket.
Or you
And
can
when you construct a scanner, one of the ways to construct a scanner is with an input stream.
Oh.
And when you have a print writer, one of the ways to construct a print writer is with an output stream.
Cool.
So let's write some code. So I'm using something different here to deal with exceptions. I'm being sloppy. When we have code that can throw an exception, we surround it with a try-catch block, right? And if something goes wrong in the try block, it'll jump down to the catch block. The alternative is to just declare that your method can throw an exception. And then if something else was calling this method, that thing that's making the call would have to go inside a try-catch block or be in a method that's declared as throwing an exception. Since this is my main method, I can just say this can throw, and I'm just going to say exception. It's the most general version of an exception. And now I can have code in here that might cause an exception, and the compiler won't complain. But if I run this and an exception occurs, it's just going to throw up on my screen. So we're going back to where we can basically do a seg fault. But that's just to save myself from having to write 1,000,001 try-catch blocks. But do try-catch blocks normally, because you want to handle these things gracefully. But I'm going to be lazy here. So what are we going to do here? So I'm going to make a socket called sock. And I'm going to connect to our local host, that's this laptop, and I'm going to connect to port 1210. Why? Because I might have something listening on 1210 for connections. And I'm going to create a scanner to read standard in. going to want some input and output streams, so let's see. So I'm going to make a scanner for reading from the server. I'm going to call it from server. And I'm going to construct it as a new scanner of type sock.getInputStream. And I'll make a print writer to go to the server. So that writes to the server. And then we can just sit here and loop. So we'll read a line from standard in. And to server.println. So we'll send that out to the server. And when we deal with sockets like this, we're going to want to flush. Because this will definitely buffer things up, because socket connection is expensive. You have to send a bunch of header information to indicate what you're sending, and generally, unless you tell it to, it's going to save all that up until it's got a big bunch of characters to send, and then it'll send them all out at once. So we're going to force a flush so that whatever we type in our line when we hit enter, it'll go ahead and actually force that out to the server. So we'll force that to send immediately. And then let's read from the server, and so we're going in lockstep here. I'm assuming that every time I send something, the server is going to send something back. So so we'll just call next line. And then we'll print it out. And we'll just loop like that. So we'll read from standard in, send whatever we typed out to the server, read one line from the server, display it on standard out, and we'll just iterate. And when we hit Control D, we'll exit this. So let's go ahead and close down the socket connection. And that should be our code. So we got to do some imports. Print writer. What's my other version?
You gotta import DIO.
Oh yeah, input stream and output stream. Input stream, output stream, print writer, scanner, socket. Is that all we got?
First you gotta import throws declaration as well.
Say what?
First you gotta import throws declaration as well.
That's not an import, so it should know about exception.
Really? 'Cause Eclipse imports that when you.
Really?
Yeah.
Oh, let's live dangerously. Got a twiddle. Hey, not bad. All right, so I'm going to go ahead and run this, and presumably I've connected to a client, to a server, and I type in something and hit enter, and I get back this string showing me what the square of the thing is that I typed in. So I've got a server sitting on my machine running, and it's a square server. So I can type in something like this, and it gives me back the square of whatever I type. And I can control D it, and I can run again, and it's still doing its thing.
So you control D it, that puts the background, right?
Control D is end of file.
Well, that's, I'm thinking Z. So what are you trying to do there? Like, why isn't the file quit the program or send you back to terminal?
Why isn't what?
Why is Control D sending you back to terminals?
So let's look at our code. So this is my main loop, right? And when I hit Control D, has next line will fail, and then I just close down the connection and I exit.
Okay. But is the other loop still going, or it's trying to?
The other loop is still going.
How would you close that if you accidentally screwed that up?
Close what?
Well, if you were doing that and you press Control D to end the file, but the other loop is still going, like in any thread situation, could you just end it like you would any program?
So, yeah, but this is going to be one of your challenges in PA5 is how you shut down things at the end. Because your server can keep running, but your client, if your client exits, your server needs to somehow know that your client exited, and it's got to handle that gracefully. So it can't be sitting there waiting for more stuff coming from the client if the client has gone away. It's got to know that. So you're going to have to do some sort of communication or some way to detect that, and that's going to be slightly tricky because you got two threads over on the server side. So that's something to figure out.
And you want us to use Control Z, right?
Whatever your end of file is. If you're on Windows, it'll be Control Z. If you're on Mac, it'll probably be a meta key something. But if you want to have a particular exit command, like !exit or something, that's fine. But you'd like to be able to handle the case where the user just hits Control C and exits. So will that destroy your client, or will it be able to continue functioning, right? So there's ways to do those things. All right, so this is an example of client code, right? And it's really a little bit of setup, right? Creating a socket that talks to the server. So that's that line right there, socket localhost 1210. Setting up some I/O channels, right? An input stream and an output stream. And then whatever you want to do in your loop, okay? So that's going to be different depending on what you're trying to do. But it can be as simple as read a line from standard in, send it to the server, right? But again, this is moving lockstep. So if the server didn't happen to have a reply after I sent, this is going to block down here until the server sends something. So that's where you want to break it into threads. And this server that I have running doesn't care how I connect to it. So I do have Telnet sitting on this machine. And I can ask Telnet to connect to port 1210. And it's talking to the same server. Right? Now Telnet just waits for you to type something, hit enter, and it sends it. And if anything comes in from the server, it displays it. Right? So it's kind of doing the client side for us. So as you're developing the server, you can put Telnet on your machine if you want and use that to talk to your server, or you can use PuTTY, right? Just tell it to use Telnet instead of SSH, and that can play 1/2 of your PA5 for development purposes. Yeah.
If you have Netcat installed, you can actually have it do either half.
Oh, cool. It'll serve?
Yeah.
Cool. Okay. So do netcat. But don't make your Java program just a system call to netcat. All right, making sense? So client-server code is potentially interesting to develop. And probably one of the more challenging parts is sort of being able to think of two sides of the process, right? And getting things going in the right order. Complicated by the fact that this side of the process actually has two pieces to it, and the server side also has two pieces. So you kind of have 4 threads running that need to somehow do the right thing. For me, sort of, putting things in temporal order, but having a client-server side, right? All right, so down here, we're connecting to localhost 1210. Localhost, remember, is a pseudonym for our current machine. But if I were to put in the IP address or the DNS served name of a machine anywhere on the internet, and that machine was running server code, theoretically I could connect to it. So I could run the server up on the space station and put in the IP address of the space station here and connect to it and have a program on the space station calculating squares for me, right? So this gets you right to other machines as well as your local host. For development purposes, play on your local host. It's easiest. You don't have to worry about firewall issues and so on and so forth. But as you develop this, right, keep in mind this can be a machine anywhere that you have network access to. So I have a router that I'm going to, I haven't figured out how to do this. I think I'm going to just put it in the collaboratorium with a power box. And if you want to use that, you can turn the router on. And if you connect your network to that router, and somebody else has their machine connected to that router, you can run the server code on one machine, the client code on another machine, and do the same kind of communication. And your chat program should automatically work from one machine to another. It's just instead of saying connect to localhost, you put in the IP address of the machine you're trying to talk to. So once you get this working on one machine, it works across the net, right? Across the lab or across the planet. But it's hard to do on Clark's network, because Clark's network has all these firewalls and strange things they do with IP addresses. So even though 2 machines are both connected to Clark's network, it's really hard to put in the IP address of one and get to it from the other. But like I say, I'll have a local router sitting in the collaboratorium. You can connect to that and connect machines that way. Does that make sense? All right, so tomorrow we will talk about the server side of this. So I'll show you what the server is that's running, and it's almost the same thing. It's a different way that you create a socket. So we'll talk about the server side, and then we'll talk about Lab 5, so you can get that going sooner rather than later. All right, so I'll see you tomorrow.